Okay, motion of projectile, as you learn in your metrics or A levels or your fundamental, you know that projectile always moving in this way means you launch from one place, you will land somewhere here or somewhere here. So when you learn about projectile, all the cases will have the effect of gravity. Have an effect of gravity. So we always start defining object or particles. We start with the axis, x and y, and then the red dot on the Cartesian plane. You know that you always have a beginning position, x0, y0. Okay, then you will start with the velocity, initial velocity. So velocity is a vector. Vector you can split into x and y. So if you are still don't know how to break the vector, recall trigonometry, triangular equation. Recall what is tangent, what is sine, what is cos. Okay. So, for example, I write something on the whiteboard. So tangent is opposite divided by side. So A, B. Sine is opposite and hypotenuse. Cos is side and hypotenuse. So it depends on what is missing and you use that one. So there's an angle over here. We always give priority to the horizontal or the ground level. Okay, so anyone you don't know how to split vector? You don't know. Don't know, If you quiet, I assume you know. Okay, so this one you split into two directions, x and y, by using trigonometry equation. So since we are talking about projectile, projectile will look in the curve way. So curve, you know, you deal with quadratic equation. Okay, so let's say this particle move along the projectile curve, and it will give you a new vector. However, in this case, your acceleration on the Earth, you deal with gravity. You deal with gravity, and most of the case for chapter 1 question, it will ask you to ignore the air resistance. So you only deal with gravitational force. The constant value we use here is 9.81, and with the negative sign. Why negative? Because before we start any problem, we already define to the right is positive, going up is positive by referring to your primary axis, x and y. It will also, once you establish where is your positive, negative, then your equation will change. It will change, positive, negative sign. So throughout this module, all our direction go up normally, we'll use the go up positive. So your acceleration or gravitational force acceleration will be negative 9.81. So your velocity, you should know if by looking at the screen here, you know that velocity always tangent to the curve. Okay, tangent to the curve, and apply the same. This is vector. Vector you can split into x and y position. So you split into x, you split into y. So don't draw this one y pointing up. If you draw pointing up, means you don't know how to split vector into x and y. You open up your finger lah. So it's always like that. Okay, like that. So once you have this one, then you in your solution or in your answer sheet, you always break your question your solution into two parts. Right? In your answer sheet, you can do it. I always do left, right. You can do top and bottom. But in the PowerPoint slide later, you'll see top and bottom because of the space that I have. Right? So on the left, normally we will look at y direction. On the right will be x direction. But sometimes it depends on information I have. But I always look at one direction and another direction. So y will be vertical direction, x will be horizontal direction. Then after that, you combine what you have, you solve simultaneous equation over here, you'll get the missing parameter. Okay. So this is a Cartesian plane, and later when we talk about curvilinear motion, later after this one, you will define something in polar coordinate where you see r vector there. Okay, there's a quick video where people done experiment on the surface of moon. Surface of moon don't have air, it's a vacuum state. So what happens if you drop a hammer and feather in the vacuum? So later you'll see astronaut holding a hammer and feather. So which one will drop first? Which one will not drop first? Which one will touch the ground first? What do you think? What do you think? Hammer or feather? Which one? Huh? Both same time, huh? So yeah, so this video proof the so you see both objects reach the ground same time in a vacuum condition. Huh? So we continue. Recall the three equations that you have that I mentioned before we start the class. So these three equations is very popular in chapter 1 and chapter 2. Okay. So chapter 1, it deal with projectile, and or you have the constant acceleration, then you can use these three. Okay, first one, V equal to V O plus acceleration time S. When you pull this one to the left, you'll get change of position or displacement equal to ut plus VOT plus 1 over 2 AT square and V square and so on, like what you see on the screen. So how do we solve problem? Normally, we will split our solution into two parts, horizontal motion and vertical motion. Means that we don't confuse ourselves. We focus on one motion and then continue with another motion. So let's look at horizontal motion. So this is a free body diagram with all the motion that you have, velocity vector that you have. So in the x direction, horizontal, and we define x to the right is positive. So when you solve your question, when you get negative, it means the parameter that you're solving is moving opposite the direction of your x. All right. So horizontal position, your acceleration is 0. Why 0? Why your acceleration x is 0? Why? Gravity is what direction? Y direction. You know that, again, it's still back to vector. Huh? Vector, you can split to x and y direction. If you only have one direction, one vector, then there is no vector in other axes. So for horizontal, you don't have acceleration. Huh? Horizontal velocity. Okay. So here, when you talk about acceleration here, is about gravitational force. Okay, gravitational force. Okay, so you can use this one. So you cancel the A inside the formula, the first one. So you will get your Vx will equal to Vox. means the direction, because we are looking at horizontal motion only, so don't confuse with the other. We're looking at horizontal, so you only have Vx starting, right? And the n. So you link with this formula, you'll get Vx equal to Vox, means the n Vx component vector was same as the early velocity vector. You look at the second equation motion, right? This one. So again, you apply the same. You don't have acceleration in x direction. So change this direction to all this term in x direction, right? So you cancel the second one, you will get this formula. You change the s according to the coordinate system you have. Coordinate system you have is x and y. So you change the s into x. So s is the final position on the graph is x. SO is the initial position on the graph is initial position x sub 0. So you just replace this term into the correct one. Then this one, VO, you replace with the equation above. VO equal to VOX. T copy, and this one 0. You look at the third one, same. AC 0. So this one 0. Square here. You take out the square. It basically prove you to the first equation in the green here. Okay, you get the same equation. This one equal to this one, same, same thing. So we are done for horizontal motion. In your test or final exam, you need to write all this out. You need to develop this one, and then only you can do. So you start with these three equations. X direction, A0, you write all these things. Then you do for the Y, for the vertical. Can I? Okay, look at vertical, you apply the same. Y direction go up positive. Your A now is negative G. Okay, negative G. Let's see what happened. So you pull the first equation, change all these terms inside this equation into Vy, Voy, ACY, and T. So this one will become Vy equal to Voy minus GT, because the acceleration is negative now. Why negative? Because direction go down, and you define Y positive go up. Important, always define where is your principal axis before you start. You apply the same for second one, you will get this one. Change your S into Y coordinate because you're looking at vertical motion. S change to Y, VO become VOY, and AC change to minus G. Okay. The third one, same. Third one, change the V equal to Vy, AC change to G, minus G, S change to Y, you'll get the third equation. Most of the time, mistake done when they do the vertical direction, the vertical motion. They forget G is negative. Okay. Let's look at this example. A sack slides from a ramp with the horizontal velocity. You know that once you see horizontal acceleration, horizontal velocity, it means along the x-axis. So if the height of ramp is 6 meters, so 6 meters from the ground, determine the time need for the sack to strike the floor and range of R where the sack began to pile up. What does it mean? So you have to use your simple logic. When you slide this one out, it will not go in straight line. It will not go like this, but it will go like this. It will follow this path, not straight line. Straight line is if you move very fast, but normal one, if move slowly, it will follow the curve, right? So this is the R that mentioned in the question. In final exam or test, you won't see this arrow. You only see the diagram, the parameter. A, this one won't be given. This is just for remind you on the effect of gravity. Okay, how do we solve? Again, SOP still the same, the procedure still same. You break your solution into two parts. You look at horizontal and vertical. We start with horizontal. So I will not go back to the derivation just now. So you know that if you look at horizontal, your Vx equal to the Vx final equal to initial V. Your position become this solution, and your same, your velocity also same like the first one. So you know that the initial is 12 meter per second. So you know that initial Vox is 12. So your final velocity is Vx. Vx equal to 12. Then you modify the equation. You need to find the R here. The R actually is the location at B. You assume this one 0. This one is B. So I just put R as a final location. Right? XA means your X position in A over here. Right? So you substitute the value, your R, or you can write as BC or CB, same. As long as you have something that explain about your diagram. Okay. So you substitute the diagram. Okay. Then you look at vertical. Vertical, you have another 3 equation. Pull out the 3 equation. Okay, again, go back and review how we develop these 3 equation by substituting the negative G inside the AC place. So vertical component, I choose the second one. Of course, you can go and choose the first one. You can choose accordingly, but normally these 3 equations will help you. So I start with the second one. I replace what is the y. Y is the final location. E in y term, because we are looking at vertical now. So initial YO means initial location in y position, where is YA here. Then you replace the initial velocity y VOY here with VAY t minus 1.2 gt squared. You substitute the value. You know your by is below horizon. Below go down negative. So normally careless mistake over here. You always assume all the value you do is positive. That happens when you do statics. When you come to engineering dynamics, you will deal with negative sign. Quite a loss of time. Right? So remember, this is the original location given by the question. This is your origin. Anything go to the right is positive, go to the left is negative, go up positive, go down negative. YA 0 here, VAY is 0. Again, why your VAY is 0? Because you are given horizontal speed. You know that when you break vector, this one is 100% to the right already, so you don't have vector go up. Okay. Then you substitute all the value. G is 9.81. For this module, avoid using 10 for gravity unless the question asks you to do so. Okay, so in your solution, if you use 10, I will not give you marks. Okay, because you are now at the degree level, you're not at a certificate level. If you do certificate, then I'll give you correct. But if you do degree already, then you should use more precise number. Okay. The reference answer for you, you'll find the t equal to 1 point something second. Again, you need 2 decimal place for this module, maximum 3 decimal place. Remember the unit. If you miss out the unit in your answer, automatic discount 50% from the marks. If this costs you two marks, without the unit, you only cost you only get 1 mark for the answer. You do the same. Once you have the time, you substitute back to the equation here, right? You have two side of solution. One is horizontal, one is vertical. So you can balance check whether you have answer on the left or on the right. You substitute back, you get your R. You get 13 point something. Okay. Any questions so far? The procedure always same. Look for the coordinate system. Where is positive, where is negative. Then every time you see there's a projectile question or something fall from somewhere, throw something from somewhere, then it's fall under projectile question. Projectile question straight away, break all the component into X and Y, then break your solution into left-hand side and right-hand side. Left-hand side do the horizontal, right-hand side do the vertical, and so on. Then you are solving simultaneous equation. Okay, and every time deal with projectile, then recall the 3 equation. Three equation. Okay, one more example before we go for a short break. Okay, or maybe we continue. We can continue. Okay, we have a chipping machine. So most of the time in Malaysia, we didn't see this machine. Right, chipping machine means you throw something in, you wood then you will recycle the wood chip there. Then you are given a velocity of a wood chip. V initial is 7.5 meter per second. If the tube is oriented 30 degrees from the horizon, so this machine, this head here, you can tilt it up or tilt it down so that you can control the spraying direction. The output direction. So it will look something like that. So you can control the head here. So it will tell you that the setting was at 30 degrees from the horizon, and determine the height of H. The chip strike the pile if it land on the pile 6 meters from the tube. So it will look something like this. You draw X and Y will be given in a question, and this is the velocity given in the statement. Initial velocity is 7.5. The direction was 30 degrees. Okay, then you know that all this line, okay, of course, in the test of assessment, you won't see the path line. You only see the object, the reference axis, the final location or final products, and so on. And in this case, we assume the H is more than the height of the machine. Although it looks something like this, but it can be higher than the. It can be higher or can be lower. Okay, it depends on the assumption. Okay. So how do we solve? So again, first step, break your vector, all the vector into X and Y. So you have first vector here, 7.5, break to here, and Y. Right, so this one will be 7.5 cos 30 in X direction. This one will be 7.5 sine 30. Okay, if you don't understand, go back to the trigonometry diagram. Okay, any question for the splitting the direction? Okay, You vector, you have magnitude and direction. Huh? Then recall that in initial here, this is the final location that we are interested in. So you know that from the derivation equation, again, in the test or exam, you need to derive the sixth equation. 3 for the vertical, 3 for the horizontal. Derive that one, then only you come to solve the question. So your Vx, you know, is 6.5. And in your diagram, remember to draw the direction of your acceleration going down. Okay. This one will cost you 1 mark automatically if you draw this in your solution. This is a free mark. So if you draw this one, you'll get 1 mark. Okay. Okay, horizontal, vertical motion. You recall the equation just now, the 3 equation, right? Then I choose one of it. First one you already solved already. First one you already solved. Vx equal to Vox is this component equal to this component here. Then you go for second one, you change, rearrange a little bit the equation. You change a little bit, x become xa. This is the final position in x. This is the initial position in here. Vox, like the previous one. T, you don't know. You substitute, you get this one. Again, in this case, your x is positive because it's going to the right. If we spray to the left, then negative. If spray to the right, means positive. You substitute, you get your A to reach A position. You go to the vertical. Recall the 3 equation for vertical. Again, you need to derive this 3 equation. You apply the first one, second one, third one also can. But in this case, I use the second one. So I modified the equation. The first y is the final y location, initial y location, and so on. So you substitute the value that you know. In this case, as you can see on the screen here, I assume h is higher than my machine. In my case here, my h is, I assume higher, I take h minus 1.2. You can take 1.2 minus h also can, but you will get negative sign. If the final answer come negative, means it do not agree with your assumption. Okay, you substitute, there's only one unknown, you'll get h is positive value, 0.45 something. Okay. Same answer if you try to apply for other things, other equation here. All right. So with this, we conclude chapter 1, session 1. We have another. Yes.
You don't have to derive it from scratch.
You need to write these 3. Derive for the horizontal, derive for the vertical. Okay. These 3. X1 is yeah, you derive lah. Y1, more important, Y1 is the gravitational, is negative going down. Yes. Huh? You can skip lah, but you might when it comes to final, your memory have something deal with your memory. Or you won't. Sometimes you will memorize the wrong one. You can straight away write all this, no problem. But once you memorize the wrong one, especially a positive negative sign, this one, for example, then it will snowball to the rest of the answer. You wrong one answer, the rest is wrong already. So I recommend go for the safe way, better derive. Hold on, I stop the recording.